Okay. Yeah, so happy weekend. And I just want us to, talk about chemistry. Whenever I'm talking about this course, I'm just so happy, so glad, and yeah. So I want us to talk, how to really study the biochemistry that you enjoy. It's been, chemistry, we have different ups and downs. Here to tell you that biochemistry is as easy as possible. No, are we there now? There are challenges that you will encounter, especially when you don't have anybody that has studied the course that you know. Are we there now? That's where I come in. You can always ask me your question. You can always, come to me to discuss any problem about the course, and then we can see how far we can solve it together. Are we there now? It's as a result of the love for the course that I even had to start my postgraduate program. Are we there now? So it's an amazing stuff to do. Don't regret it while your mate, every other person is studying medicine, and then you feel like, I'm a failed individual. Hey, I know I'm going to die. No, it's not a failed venture. It's you know, more like sacrifice. I think that's the word. More like trying to sacrifice whatever you are going to do. You understand? It takes hard work. There's a video I recorded recently that I'll be uploading on Monday. Where I was talking about the reason why I didn't graduate with a first class as an undergrad when I was an undergrad. You understand? It takes a whole lot of work. It takes hard work. It takes seriousness. It takes dedication. You understand? And then, as a young person, one of the mistakes you ever make is, not sacrificing whatever you have now and then relaxing, hoping that tomorrow it will be easier and better. Are we there now? I don't know where you're coming from. I don't know, the life you have. I don't know your backends. I think that's the word. But I think that no matter who you are, what you're doing, so far as you're studying this course called biochemistry, you need to impute the work, especially if you want to do something for humanity. You understand? Especially if you want to impact lives of people, you have to impute the work. It's quite a hard work. It's not as easy as it seems, but it's also not as hard as people, program it to be. Do you understand? You just have to work on your own pace, know what you want. That's the specifics. Know what you want, and then you will get, your desired result. So in our last workshop, which is last week, I was talking about biomolecules, which is among the fundamentals of biochemistry. There are generally four important fundamentals of biomolecules in biochemistry. Begin to look at, the carbohydrates, begin to look at the protein, begin to look at lipids, and then begin to look at nucleic acids. Those are four important biomolecules in, biochemistry. Now, that conversation, I mentioned carbohydrates. In this conversation, I want us to look at protein generally. I would now protein is a biomolecules. When you were growing up in your secondary school, they taught you that we have what we call 6 classes of food, AB5. I can't remember. Now they told you that we have carbohydrate, protein, lipid, vitamins, minerals, and water. They weren't wrong. They are completely right. But in this conversation about chemistry, it's more like an updated version. We're no longer looking at, say, nutrients in food, but here now we're looking at, okay, what are those components that helps an organism to be a complete organism? Are we there now? What are those components that makes this particular individual to be as healthy as we can ever, proclaim them to be? Do you understand? So when we begin to look at protein as an important biomolecules, it goes beyond the nutrients that you know. It goes beyond eating egg, fish, meat. No, it goes beyond that. So in this conversation, what I want you to understand is that protein is an important biomolecules. And for protein to be formed in the body of an organism, there must be what we call amino acids. So amino acids combine in varying amounts to form what we call proteins. Are we there now? So we have different amino acids that are combined in varying amounts for us to form a protein. Do you understand? So when we're talking about amino acids, generally there are over 200 naturally occurring amino acids. But in the body of a living organism, we have 20 amino acids. Are we there now? Where we have essential and what non-essential. I don't know if you're getting what I'm saying. Now, we're not going deeper into essential and non-essential. I already have a video on my channel where I explain essential and non-essential amino acids. You can go watch it. I'll also link it in this description when we end this live. So what I'm trying to insinuate is, for us to form a protein, there must be what we call an amino acids that combine together to form this particular protein. So now, when we're talking about types of protein doesn't have a specific type. Say, okay, these are just the type of protein. When you are being asked what are the type of protein, your question you should reply, is that, okay, according to what am I going to give you the types of protein? Because now when we are being asked type of protein, we have types of protein according to function, we have types of protein according to solubility, we have types of protein according to composition. Did you understand what I'm saying? So when we're talking about types of protein, it's not just linear as per in carbohydrates, where we have monosaccharides, disaccharides, oligo, and poly. Now, in protein, we have different divisions. So if we say the types of protein, and then we begin to look at the first division, which is according to function, this is when we begin to look at enzymes. Are we there now? This is when we begin to look at transport proteins like hemoglobin. This is when we begin to look at defense proteins. Are we there now? Like your antibodies. Are we together now? And then this is also, we can also have what we call hormonal proteins. Are we there now? Proteins act as hormones, like your insulin, glucagon. They are all proteins. So when we begin to look at types of protein according to function, let's start with enzyme. Already, I want you to understand that enzyme try as much as possible to speed up the rate of chemical reaction. So anything that is called enzyme that you hear in biochemistry, I want you to also understand that enzymes help in what? Speeding up, the rate of chemical reaction. So enzymes are protein on their own. And then according to, the classifications of enzyme, we have 6 important classifications of enzymes. We begin to look at what we call oxidoreductases, we begin to look at transferases, we begin to look at hydrolysis, we begin to look at lyases, isomerases, and ligases. So those are the 6 classifications of enzymes in biochemistry. So as an undergraduate of biochemistry, you need to understand that why protein act as enzyme also has its own classification. So in the biochemistry reactions that happens in the lab, we need to understand that any enzyme that you see or you're studying, you need to understand that each of these enzymes must belong to one or more of this classification. OTHLIL. Please, if you're watching the video, please give us a thumbs up so that YouTube can recommend this video to other persons too, right? Yeah. So I was saying, now I said that when we begin to understand the classifications of this enzyme, let me explain one of the classification, which is hydrolysis. It's the simplest classification here. Now, what is a hydrolysis enzyme? A hydrolysis enzyme are enzyme that try as much as possible to break down strong bonds. Are we together now? What they do is that they are enzyme that acts in that helps in hydrolysis. Are we there now? They are enzyme that use water to split complex compounds. So examples of hydrolysis enzyme are your digestive enzymes. They use water to split your food. All hydrolysis enzymes, all digestive enzymes rather, I think that's the word. All digestive enzymes are hydrolysis enzymes. And examples of digestive enzyme, we have what we call amylases. AMYLASES. Amylases are digestive enzymes that act on carbohydrates. You have your proteases. Proteases are, digestive enzymes too that act on protein. You have your lipases. Lipases are digestive enzymes that act on lipid. Did you understand? So when we're talking about digestive enzymes are under hydrolysis, which is a classification of enzyme on its own. So when you begin to read your research paper, for those of you that are still young about chemistry, you begin to see what we begin to mention EC1 enzyme, EC2, EC3, EC4, EC5, EC6. Those are enzyme classification. Enzyme classification 1 is enzyme classification 1, which is what? O, oxidoreductases. If you see EC2 when you are reading a particular research paper or in a textbook, EC2 simply means T, which is transferases. If you see EC3, it's number 3, which is what? Hydrolysis. And then you continue with LIL, ligases, isomerases, and lyases, and all that. Are we there now? So one of the functions of this particular protein is that it acts as enzyme. Now the second one is transport. Enzymes, proteins also act as transportation in the body, like your hemoglobin. Are we there now? Hemoglobin is a globular protein. When I will be explaining the solubilities of proteins, I will explain to you what I mean by globular proteins. Just don't click off. Watch to the end. Work with me. Do you understand? So now I said hemoglobins are they help in transportation in the body. Are we there now? Remember, they carry oxygenated blood around the body. Are we together now? So that is that for transport proteins. We also have what we call defense proteins. Now, I want you to understand something. How many of you have watched this movie called Gladiator? Do you understand? In Gladiator, we have those that fight with knife and we have those that hold shield. Do you understand? Now, when they have a shield is more like for protection, and you use knife to attack, and use shield to protect. So when we are looking at that shield is more like an antibody. Are we there now? The shield is like an antibody in the body of a living organism. So when you usually have, say for instance, you usually have, um, microorganism, harmful substances that intrudes or is being introduced into the body of an organism. What provides the shield, or what help in fighting that shield, in fighting that particular, microorganism or harmful substances? We usually call them, antibodies. So if you don't call them antibodies, you call them immunoglobulins. If you don't call them antibodies, you call them what? Immunoglobulins. Now, let's go down a bit to basic biology. Now, there are 5 different types of immunoglobulins. In basic biology, I told you immunoglobulins is something as antibody. What are antibodies? Antibodies help in fighting against foreign substance. They act as shield. They shield the body from, the harmful effects of harmful microorganisms. Are we there now? So now, there are 5 different types of immunoglobulin according to your basic biology. We know them with the acronym GAMED, GAMED. So we have immunoglobulin G, immunoglobulin A, immunoglobulin M, immunoglobulin E, and immunoglobulin D. Are we there now? So those are the different types of what? Immunoglobulin. They all help, in safeguarding the body from what? The harmful effects of foreign substances. Foreign substances are not substances that are made in, United States, or foreign substances are not substances that are made in Espanol. No. Foreign substances are substances that are not, recognized by the body. They are more like they are new to the body. Do you understand? So in this conversation now, we're going to say that, all those infections, they are all foreign substances. The body doesn't recognize them. So when they are introduced into the body produces an antibody against it. You understand? So that is that. So proteins can act as enzymes. They can act as defense, that is in producing, antibodies. So antibodies are proteins. Proteins can also help in transportation. Now, proteins, act as hormones. Insulin, glucagon, adrenaline, they are all hormones. Of course, the functions of this hormone. They help the body to control activities like insulin, helping to regulate blood sugar. Without insulin in the body, diabetes will be the order of the day. What is diabetes? Excess of sugar in the what? In the blood. Not excess of sugar in the body, excess of sugar in the blood. So without insulin regulating the amount of sugar that enters into the blood, diabetes will be the order of the day, to be a lifestyle. Do you understand? So protein also provides what? Hormonal function. So these are the few, functions of protein. Are we there now? So when you are being asked types of protein, I've explained protein type according to function. Now let's move on to protein types according to solubility. Now, protein types according to solubility. So what is solubility? Solubility simply means, are you soluble in water? Are you soluble in fat? You understand? So when we say that, we want to look at proteins according to solubility, there are 2 different types of protein according to solubility. Have what we call the fibrous protein, and we have the globular proteins. The fibrous protein and the what? And the globular proteins. What are fibrous proteins? Now, fibrous proteins are proteins that are insoluble in water. Fibrous proteins are proteins that are what? Insoluble in water. Are we together now? Now, when we're talking about proteins that are insoluble in water, look at your hair. Do you understand? Now, this your hair, there is a particular protein found in this hair called collagen. Are we there now? Now, collagen, keratin, those proteins are insoluble in water. So, since they are insoluble in water, what do we call them? We call them fibrous protein. So, whenever you hear about anything called fibrous protein, I want you to understand that fibrous proteins are proteins that are what? Insoluble in water. Please, if you're following, drop a comment, and like the video so that it can get to a wider audience. Drop a comment if you're following. You can drop a comment and maybe like the video so that YouTube can also recommend. Are we there? Okay, so I've explained fibrous protein. Now let's move on to globular proteins. What are globular proteins? Remember when I was explaining hemoglobin, I told you that hemoglobin is a globular protein. So what is now globular proteins? Now globular proteins are proteins that are soluble in water because hemoglobin is a globular protein. Do you understand? So proteins that are soluble in water are called what? Globular protein. So we mentioned proteins according to their function. We looked at enzyme, we look at transport protein, we look at defense proteins. I would then we look at which other protein do we look at? Defense protein, transport protein, hormonal proteins, and enzymes. So now we're looking at proteins according to solubility, which I've explained, fibrous protein and globular proteins. I would then. So when you hear about fibrous protein, understand that those proteins are not soluble in water. You hear about globular, those proteins they are soluble in water. Now let's look at the third classification there. Now we can also try as much as possible to classify proteins according to composition. This is where we have simple proteins, we have conjugated proteins, and we have what? Derived proteins. I said that proteins can also be classified according to composition. We have simple proteins, conjugated proteins, and what? And derived proteins. Composition simply means what are they made up of? So remember when I told you that the almost all protein that exist are made up of amino acids. Hello, are you getting what I'm saying? Proteins are made up of what? Amino acid. So when we're looking at proteins according to composition, we're looking at what are they made up of? Do you understand? So here now, we're going to look at simple proteins. Of course, they are made up of amino acids. We've been saying it since the beginning. Did you understand? So simple proteins are proteins that are made up of what? Amino acid. Amino acid like glycine, alanine, valine, leucine, isoleucine, methionine. Are we there now? Aspartic acid, glutamic acid, asparagine, glutamine, histidine, phenylalanine. There are 20 of them. Out there. Even when I was explaining amino acid, I told you that there are 21 actually. 20, there was a new one that was established when I was in my final year in university. Selenocysteine or selenocysteine. Out there, which is the 21th amino acid. But scientifically, we don't really recognize that for now. We just use the 20 that we know, informing the proteins. And so these simple proteins are proteins, that are formed from the different combination of amino acids. So when we have amino acid in varying number combined together, what they're going to form? They're going to form what we call what? A simple protein. Now, in conjugated proteins are proteins that are formed from other components. Are we there? Like nucleic acids, carbohydrates. Are we there? Now they are more like a force proteins. Did you understand? They're not formed from amino acid alone. They are also formed from other components. Your nucleic acids, your carbohydrates, and all. Are we there now? That's conjugated proteins. Now we're going to look at derived proteins. Now derived proteins are proteins that are formed from the products of these initial proteins. Are we there now? They are formed from the what? The products of these initial proteins. So these are more like the classifications of these proteins or types of proteins. Are we there now? Now, but I want you to understand something. Don't just see this as a conversation of protein alone. Understand the important points I gave. Are we there now? Understand the important points I gave. If you don't have a textbook in biochemistry, I will usually recommend, it's either you take Harper's Illustrated. Harper's Illustrated is a bit advanced, a bit. Are we there now? Harper's Illustrated is a bit advanced, but you can get, a simpler version of Harper's Illustrated. Are we there now? If you really want to, study more about biochemistry, this course is amazing. So if you can invest more time, into the particular course, get Harper's Illustrated, biochemistry, or you can get Leninja. You understand? Leninja is also a nice, text on, biochem. With you can, afford the editions that you can. Maybe you don't get the latest edition, it might be very costly for you. But if you have a library in your uni, you can usually go to the library. They should have all these biochemistry books. Go through them, read them. How would they now? Go through it, study. You understand? There is nothing that is greater than being, independent in study. Did you understand? After a lecturer, finishes his class, you go into the, library, study. When you're done, you come to the lab and no. You understand? It's an amazing course. So we've looked at protein today. The other time we looked at carbohydrates. We just finished on our proteins. So in our next conversation, we'll look at the next biomolecule, which is lipids. We'll look at lipids in our next conversation. The fourth one will be nucleic acid. So we'll look at lipids in our next conversation, which is episode 3. Today is episode 2. So this is about chemistry workshop. You understand, where we come, have conversation. If you always have a question about anything, and not just the video, about any course, about chemistry, any work that you are, passing through that you still don't understand, let me know. So I didn't go to lab today, so we're just here having conversation. So let me know about your questions, and we can answer. I can also bring individuals up, that want to have maybe one-on-one conversations. I can bring them up. It's generally about the course biochemistry. There is nothing else with the lovers of biochem and all. Science for undergrad. I have something to tell you guys. I would say, I know. So, yeah, in one of my videos, maybe by next week, my regular videos, let me just give you a spoiler. I will go deeper into my, MSc, coursework. Do you understand? I've received my coursework. I'm doing about 1, 2, 3, 4, 5, 6, 7 courses this semester. I'm doing 7 courses, including research, seminar now. Are we there? So, and a total of, I will not tell you the units. You understand? So, but I'm doing a total of 7 courses this semester. It's going to be huge for me. So, I will still carry you along on the journey. I will then, it's something that, you know, is amazing. I would and that's why also I'm trying as much as possible to, make you guys to, see that this is not a mistake. You understand? Studying the course is not actually a mistake. Well, I had this individual that met me the other day, and then the individual was actually telling me that they want to write jam again, that they don't like the course about chemistry. And I know that a lot of you that will be watching this video, you can, when you look back, you say, this course, they forced me on, of course, they forced me to study it. But I understand, though, just as I did, at some point, just as I've always said, this particular course wasn't my first choice. Do you understand? It wasn't my first choice. I wanted to study medicine, right? So, but after I looked at my score, it wasn't up to, 300 and something. I had to, change to biochemistry automatically. I didn't apply to any other course. I just had to change to biochemistry. And, while studying the course, I found my feet, I found my purpose. Do you understand? I found my drive. And I hope you find yours too. Do you understand? There is nothing that is impossible on this planet Earth. So far as you want it, you can get it. It's just time that it will take. You understand? It's only time that it will take. So, yeah, that is what it is. And so I have 40 unit course and then a total of 60 unit next semester. So I'm going to have, throughout my program, my 4 semesters is going to be, about 30 units. You grab, so it's going to be huge, And I can't wait to share the good news too. So please and please, you know, whatever you're doing, just as I've always said, it's all about, the tenacity, the amount of work you put in. Whatever you want, another person wants it. You're not just the only person. Another person wants it too. So thank you for always coming around. We'll have a conversation on lipid in our next class. next workshop, next discussion, please invite your friends. It's always 12 p.m. on the dot. We don't wait for nobody. It's always 12 p.m. on the dot. So invite your friends, call them to join us, and it's going to be an amazing session. It's going to be an amazing session for you. So yeah, thank you, and have a lovely day. And who is on the chat? Can you drop a comment? There are people that are joined. When they join, they leave. They join, they leave. Maybe it's network. Well, I hope you can hear what I'm saying though. You grab it will be so abysmal that after all this conversation, you didn't hear me. Hey, I'm going to be devastated for you. Right. Okay. Yeah. Thank you for watching. Thank you for joining me today. I really do appreciate. It means a lot to me that people joined and then they heard me talk and I will there. It's not like that is good in my voice. That is no good. It's just a regular person also talking. So yeah, thank you for watching and have a lovely day. Have a fun-filled Saturday. Make yourself happy. Bye. All right. Now I'm about to end. A lot of people are joining. People don't want me to end this life. I will end it. I am done with what I want to say then. So bye.